Hi class, welcome to today's lesson. So today we will talk about the composite bodies for calculate the center of gravity. So let's do some very quick review from last lecture. From last lecture, we learned how to calculate the centroid of the body, okay, by using this equation. Integrate of the y tilde You can also find these equations in the FE packet. So for this class, okay, sometimes we can also express summation of x tail dw over summation of the dw and the y summation of the y tail dw, sum of the dw. For the z can be sum of the tail dw, sum of the dw. Okay. And also the w can be replaced with mass, area, and volume. Okay. So that's pretty much we learned so far. So today we will get started by talking about the composite body. Okay. So what's a composite body? Last lecture we talked about the centroid for rectangular, circle, square, but in reality, so not all the structures is just as simple as just rectangular, as a circle. So which means in the reality we should be able to calculate a series of connected shape. Okay, let's put a series of connected simple shape, and each simple shape could be square, circle, triangle. Okay, by connecting the simple shape, we should be able to calculate a more complex shape. Okay, that's how we define our composite bodies. Okay, but how? Last lecture we already know how to calculate the centroid of a simple shapes. We can calculate the centroid of a composite body by knowing the centroid of each simple shape. Okay, by knowing the centroid of each simple shape, we can know centroid of complex structure. Okay. So how could we do this? Let me show you. So first, as we discussed, we need to divide the body, like a composite body, into pieces of no shapes. Okay. Usually, every shape has a positive weight. But what if it's a whole? The whole will have a negative weight or mass or area, depends on which we are calculating. And then let's make the table, because we already divided our body into different sections. We definitely need a segment ID 1, 2, 3. It depends. It could be has only 2, or it could be increased to 5, 4, 5, 6. It depends on how many segments we have. But for the last row, we definitely need to write a summation. Okay. Second column, weight, mass, okay, volume, area, depends on which we are calculating. Third column, centroid. Okay, centroid for each simple shape, x tilde, y tilde, and z tilde. Results, okay, like what's our intermediate calculation. And then found x, y, and z axis, and found centroid of each piece to fill in table. And the summation of column gives x bar, y bar, z bar by using formulas like x bar equals to sum of the x tail a over okay. So let's see an example. So here is a composite body. We want to find the centroid center of the volume. Okay. So we have 3 blocks. Okay. Let's define first block here as A. This one is B. This one as C. Okay, we need to find. We have ABC. From the center of the volume. So first, let's calculate the volume of A. Volume of B times H times by ways Okay, and then let's draw the table. We have segment ID, volume, X, Y, Z, okay. We have A, B, C, and summation. Okay, so for the volume, just write down our answer. And XYZ is the centroid of each one. Summation is 3.6. Centroid of each one. So for the shape A, centroid of X will be 1.0, Y will be 0.25, Z will be 0.6. For the B, X will be 2.25, Y will be 1.25, Z will be 0.9. For the C, will be 0.25, 3.0, 0.6. And X times by the volume will be 0.25, 0.1669, 0.49. Okay, you can use a calculator to help you with this. Let's do the summation. Let's finish the summation. Okay. And the central of volume for the whole composite body, X will be summation X2 times V volume, summation of volume, which will be okay. I hope you'll get the same answer. If you have any questions, feel free to ask me. Let's say another question. So we have a shape like here from the centroid. Okay. So first we need to cut this one. Like A is a triangle, B is a square, the whole square, okay. C is a quarter, quarter of a circle, and we define D as half of the circle, okay. And the equation, in case you forgot it, so area of the circle, pi times r squared, or, okay, pi over 4 times d squared. So the shape for the A, okay, I hope you can calculate by yourself very quickly. The shape for the C, okay, is 4 over 1 times by pi r squared, okay, because it's a quarter of the circle. That's why we have 4 over 1 here. The answer should be this one. For the D, we put a negative because D is a whole. The area is negative. Okay. And externality for the half or quarter circle is 4r times by 3 over 3 pi, okay? That's in the FE packet, which means for the C, it's 4 times 3 over 3 pi, okay? For the D, 4 times 1, 3 pi. For the Y, it's 4r, 3 pi. Same thing, C is 1 point. One, two. D is 4 times 1. Three pi. Okay. For the X, the D, it should be 0. Okay, for the X, because D is just centromatic. Okay, around the Y direction, Y axis. So it's X. It's centroid on the Y. On the X should be 0. What's next? Then we should draw the table as we did before. Segment ID. let's fill in the table. X times by A. Okay. Y times A. Okay. So that's pretty much for this problem. Just pay attention for the whole, like the segment D, area should be negative. Okay.